In this video, we're going to go through page 512, which kind of gives you little examples of how we can apply all of the definite integral rules that we used on that we discovered on the previous page. I'm going to go through all of these kind of one after the other. But what I want you to do is kind of pause the video and look at them and see how many of them you can solve based on applying the rules. And then you can use this video to check your work. And as you learn new things, maybe you want to pause the video and see if you can attack problems that you had trouble with in the first shot. So give yourself as many opportunities as possible to answer these questions without as much as my help as possible, and then use this video to kind of double check your thinking and your work. All right, so what we have here is they're giving us they're not telling us a lot about this function, but they are telling us that the definite integral of the function from 0 to 3 is equal to 6, and the definite integral from 3 to 7 is equal to -8. And so based on that information, they want us to calculate all of these other definite integrals. So as I say, give this your best shot. Okay, so this first thing is talking about the definite integral from 3 to 0. So this is a weird order to us. We normally have the higher number on top and the lower number on bottom. And so what we can use, think about on the first page, which kind of rules we can use to evaluate it when the bounds are in the other order. Well, this is an application of either rule 3 or 4, depending on your mood. And so this is just saying that we can take the negative of the definite integral from 0 to 3 of f of x dx. And we know that this integral is equal to 6. So that gives us -6 as our answer. Okay, so you can see I just applied the one rule from the previous page that let me calculate this definite integral. All right, let's tackle the next one. So this is the definite integral from 0 to 7. So we don't have that whole range explored here, but we do have that range split into two different pieces. So I can use rule number 2 to say that this is, I don't know about 0 to 7, but I can get from 0 to 3 and from 3 to 7. And I know both of these definite integrals. That's 6 plus -8, which gives me a total of -2 as my definite integral. Let's check the third one. The third one, we're taking the definite integral from 3 to 3 of f of x dx. Okay, so here the two bounds are the same. So we just use rule number 1. Rule number 1 tells us that that's equal to 0. This is not sweeping out any area at all between 3 and 3. So no area is equal to 0 definite integral. All right, now we've got the definite integral from 7 to 3 of 3 times f of x dx. So there are two things going on here. The first is that we can swap the bounds of integration. And we don't know this definite integral, but we've got this constant multiplier of 3. We can pull that outside of the definite integral. All right, so we're using rule 4 and rule 5 here. And now we have this definite integral that we know. So that's -3 times -8, which gives us a product of +24. Okay, how about this next one? This is very complicated. Okay, so the first thing we're going to do is we're going to take this apart into two pieces using rule 6. Maybe I'll also pull out that 3 using rule 5 again. And just to make it kind of simpler, this is 3 to 7 of 2 dx plus 3 times the definite integral from 3 to 7 of f of x dx. All right, so this, once again, I know that's -8. How can I evaluate this? Well, this is a constant, so I can use that rule 9 that we suggested. So this is equal to a rectangle with a height of 2 and a width of 7 minus 3. Plus 3 times, we said that that's equal to -8. And so 7 minus 3 is 4. 2 times 4 is 8. 3 times -8 is -24. And so that gives us a grand total of -16 for our definite integral. So you can see that even when we've got something that's really difficult like this, a very complicated expression in here, we can just use those properties from the previous page and really take this apart. All right, now we've got a couple of simpler things, assuming that f is even or odd. Okay, so if f is an even function, the integral from -3 to 3. Remember, an even function is a function that looks like x squared or x to the 4th. If you graph those things, you've got this function which has got the same shape on the left and right hand side. It's symmetric about the y-axis. So this means that it's just 2 times the integral from 0 to 3. This whole area is just double the right-hand area. And we decided that that was equal to 6. And so that gives us 12 as our area. And now that same definite integral if f happened to be an odd function. So an odd function is one that looks like x raised to an odd integer, like 1. It would be a straight line, or 1/3. And so graphs like this are symmetric about the origin. And the area, the integral on the left-hand side is the negative of the integral on the right-hand side. So they're going to cancel each other out. We're just using rules 7 and 8 in these two cases. And so that's just, coming out to 0 as that works out. Okay, so you'll have a little bit of an opportunity to practice with problems like this on the homework page. But I'm hoping that you're kind of seeing, first of all, that the rules are easy to apply, and second, that the rules hopefully are easy for you to understand and internalize, that definite integrals work the way we would expect them to, because they're talking about areas, which is something we have a lot of experience in.